For question 4 in the checkup, we're asked to use Descartes' rule of signs to describe the roots for this polynomial function, the w of x. So remember, we just care about the coefficients. We start with a positive, then we have a positive 4, negative 7, positive 20, and we have a negative 21. So if we look for the sign changes, we see we go from positive to positive, then positive to negative, then negative to positive, then positive to negative. This represents 1, 2, 3 sign changes. That means that for our possible positive roots, we could have a maximum of 3. For our possible negative roots, we need to take the w of negative x. So if we do that, we're going to just replace every x with negative x. And we're going to get, with even exponents, the sign staying the same. With odd exponents, the sign changing. And so let's take a look at our sign changes here. We've got a positive, then a negative, another negative, negative, and negative. So it looks like we only have one sign change, which means that the possible number of negative roots is 1. So to describe all of our roots, remember we have an exponent of 4, which means we need 4 total roots. We can have positive roots, we can have negative roots, and we can have complex roots. So I'm going to make a quick chart to show all of the possibilities here. So in possibility 1, we have the maximum number of positive roots. That's 3. That leaves us 1 negative root that we can have and 0 complex roots, giving us a total of 4. Scenario 2, we can count down 2 from the positive roots, so we could have 1 positive root. We could still have 1 negative root, and that would give us space to have 2 complex roots. Remember, with our complex roots, they come in pairs. If we count down by 2 again in our positive roots, we get negative 1. This doesn't make any sense. Thus, it's not possible for us to have any other scenarios for positive roots. Same with our negative roots. That means that we can either have 3 or 1 positive roots, 1 negative root, and 0 or 2 complex roots.